Okay, this movie is about the Victorine V715 retrofit project. A V715 was an ionization chamber radiation detector that was not very sensitive and is really only suitable for use in the event of a major nuclear disaster like the detonation of an atomic weapon. For measuring lower levels of radiation for use in, checking for health hazards and for prospecting and other uses of a Geiger counter, the V17 was not really suitable. However, they are available at a low price. They offer classic good looks, die-cast aluminum frame, and that Cold War Geiger counter appearance. Okay, I am going to retrofit them with modern electronics and a Geiger Muller tube that will actually make them more sensitive than the Victorine V700 model, which has a smaller Geiger tube. Okay, next to this set I have the circuit board. Right now we're working on software. You can see the circuit board. It is about the size of a pack of cigarettes, maybe slightly smaller, and you can see the SBM20 Geiger tube mounted on top of the circuit board. Moving over here, you can see the display that's going to go behind the meter panel, the meter plastic face on the V17. It fits neatly in there, and that's it. How to get it to light up here. Okay, and what I'm going to do now is I'm going to get an old radioactive plate from after World War II, from the Cold War era, and bring it over here and show you some of the features. Okay, right now we're counting background radiation. It counts background radiation on a 15-second interval in this mode, and that gives you a highly variable reading because really there's only 5 counts. So if you get 4 or 6, you have like a 20% error in the MR reading on the bottom. The MR readings on the bottom right that devolves from that, is calculated, from that 15-second count. Okay, this has the feature, however, on the top line, I have an algorithm which does a fast integration and gives you a analog meter type response to radiation. Unlike other digital counters, you don't have to wait for a count interval, 8 seconds, 15 seconds, or whatever it might be, to get a radiation reading. And I will show you how that works. Let me get the plate over here. Okay, now so I got the plate over it. This is a beta source. You see that MR reading basically goes up and down as I move the plate in and out. It's basically just a meter. There it is. It's more or less stabilized at somewhat over 1. And you would have to wait to get the same result with the count interval, which is also available on the screen. You have to wait 15 seconds. I take it away. Of course, the interval, the reading from the last 15 seconds remains on there, while the MR, the F that's expressed as FM on the screen, goes down. Move it back. Take it away. So you get a virtually instant meter-like response to radiation level, and this is something that is not offered by the typical digital Geiger counter. They're usually a count interval type of device. Okay, and you notice on the bottom of the screen there, on the bottom right, you have battery and GV. GV is Geiger tube voltage, which is nominally 400 volts, and that a large variation in that voltage could affect the accuracy of measurement. Geiger tubes do have a plateau where they, the sensitivity doesn't vary much from, say, on this one it's probably 360 to 440 volts. But if there's some problem with the inverter and a significant change in voltage, you want to know about that. You should have a steady 400 volts. Okay, it also shows battery voltage in 0 to 100%, and the Geiger voltage and the battery voltage alternate about every 5 or 6 seconds on that bottom line. And the top right is, of course, the count for the 15-second interval in question. You can see it gets about 6 counts on a background radiation, but if I bring that plate over, you saw it counting more rapidly. And that is basically what we're going to install in this case as soon as I get the aluminum plate that I'm having made to adapt it all. And that's what we've got so far in the Victorine 715 retrofit project.